Hey, how's it going? You might be noticed that I have been missing lately. AI just fucked up everything. Anyway, let's talk about Jiggle Physics. Blender 5.2 just added a brand new experimental geometry nodes based Jiggle Physics editor. I mean, it's actually just a cloth physics thing, but I'm gonna use it for Jiggle Physics because
You promised, son.
you know why. First things first, you're gonna need Blender 5.2 Alpha. Second, what you're gonna need is to go Preferences, Experimental, and just click all of them. I don't know exactly which one of them unlocks the thing, so I just clicked on them all. I don't really care. Third, what you're gonna need is a model of, I guess, a person or whatever you wanna add Jiggle Physics to, right? This is like a very quick and dirty setup. It's very stupid, you know? It could be like way more refined than this, but I'm getting ahead of myself. So let's pretend that this like tiny animation that I did in 10 minutes, it's actually a decent and very good, very interesting, you know, very cultured animation of the kind that needs Jiggle Physics. And let's walk you through what you need to set up this using geometry nodes. Oh, just passing here to say I have a gaming channel now. I play a lot of Elden Ring. I do some challenges. I've recently played Dark Souls 1, and I'm playing Hollow Knight right now. I stream almost every day. I haven't streamed today because I was making this video, but tomorrow I'm probably gonna stream, and yeah, check it out. The link's on the pinned comment. This is what you're gonna need. Let me just delete this bake, plug it in. So this is our base animation, and the first thing you're gonna need is the cloth. So if you just search cloth, it's Cloth Dynamics Experimental. You just plop that in, and if you hit play, yep, it's just a normal cloth simulation. The model falls, everything works as intended, and is actually extremely fast. Like extremely fast compared to, you know, Blender default cloth simulation. I would add a comparison here, but there's no need to. You can just compare both of them. It's Blender's default one is trash compared to this. Of course, if you wanna do Jiggle Physics and not turn yourself into Jelly Physics, you're gonna need a pin group. So what you're gonna need is just make a vertex group here on the side, call it pin, and then on weight paint you do something like this. So red means completely no physics, basically, and as close to blue, the closer you get to blue, the more, you know, the less pinned it will be. So, you know, the more physics there's gonna be. So you just add a named attribute node right here, select pin, and you connect to pin group right over there, and just press play. You see that the parts that are 100% red, all of them are still, and the parts that are, you know, unpinned are flopping about. But that's not what you want, right? Not exactly what you want anyway. So let's make this a little bit better. First things first, let's explore some of the options within the node. First, the first panel you can open here is called Solver, and basically it's the same thing as cloth quality over here, like the quality steps, etc., etc. So sub-steps, the more sub-steps you do, the more quality you get, and the more constraint steps you do, the better your physics are gonna look, basically. So right away, I'm just gonna put this to 15, and the constraint steps, I'm gonna put it to 6, something like that. Maybe 6 and 12. There you go. Structure is one of the most important tabs here in case of Jiggle Physics, because you could just drop down this mass a lot, that it's 0.0025, like very little mass. And let's see what happens if we press play now. Yep. A lot better. Where you could basically stop here, and it would be like pretty decent. Like if I click bake, if you look this, there's already some physics going on. Whoop. So if you want to just end the video here, yeah, that's just basic Jiggle Physics. Nice. But you're gonna see that there's like a little bit of some problems here and there, some stuff that could be better. And to mess with that, you're gonna need to mess with a bunch of stuff. You can mess with basically anything. So you could, in theory, use vertex groups to control mass, to control how much like the collision distance. You could control how much damping in like in an individual like vertex level. So basically what I did is I started adding vertex groups for different stuff. So for example, if I duplicate this here and we go to weight paint, I did this mass group. Let me just hide the modifier. There you go. This mass group just says, hey, this here, blue is 0 mass, red is like 1 kilo, right? So basically it's a gradient between 0 kilos and 1 kilo, right? The mass thing here uses kilograms. You can probably change it on the units here. Yeah, it changes. So yeah, basically the mass says this is heavier and this is lighter. So if I just plug that into the mass, but now everything is broken again. Why? Because I put too much mass, basically. If I could, you could also, for example, add a math node here, and then let's say multiply, and then multiply it by 0.1, and then click bake again. And now like there's still difference of mass between like the thighs and the chest, but it's like you know, instead of like 0 to 1 is like 0 to 0.1, you know. You could also use like a map range or even a color ramp. Sometimes I like to use color ramps for stuff because it's like visually makes more sense for me. But you can use whatever, right? Because those are nodes. You could even use like dynamic stuff, like combine this with like bones. So for example, you get like the position of a bone, and then like with proximity and stuff, make things more massive or less massive. But that's like beyond the scope of this tutorial. So this is already a little bit better, right? But there's like this weird floppiness here on everything. And we solved that with, you guessed it, more and more vertex groups. And like you can really dial the physics in like really well if you want to tinker. One thing you can do that is just more general is, along with this cloth dynamics node, 2 other nodes were added, and those being, of course, the collision. Let me search collision. So geometry collider is what you need, and force. So I think the name is custom force for now. Custom force. There we go. And those do what you think they would do, right? So if you put the collider here into the effectors node, you can select, like, let's say this cube right here and mark that as the collider. Just picking up that cube. We can do relative or original, doesn't really matter. And then let's say we move this here and animated, like, let's say like frame 60, this like comes here, and you can see it's already working. And let's hide this cube just to, you know, show what's going on here. Then we can just click bake. Also simulate like other stuff, like interactions between, you know, someone and someone else, hypothetically speaking, you know. Here just got squished. So this is the collider. I'm not going to use the collider right now because it's not important for the Jiggle Physics demonstration. So let me just delete this cube. Gone. But this, we could use this for sure. So basically, if I like put like a big force in that side, it's gonna try to fall in the direction, right? So it's just like a normal point force or like directional force. You can add textures here. You can do whatever the hell you want. You can do like a big complicated node setup. So see, the force is pulling everything to the side. What I'm going to use that force thing for, though, is internal force, basically pressure. So if you add the normal, oops, Shift A, search normal. This node right here works if you plug the normal in, and let's say you add a scale, like a vector math scale, you can basically create a force that for each normal points outward, right? So this is basically the same or a similar concept to in normal cloth physics would be like pressure, right? So the bigger, the stronger is this normal force, the more the mesh will try to like expand outwards towards the normals, right? So basically, if I bake now, you're gonna see that we suddenly have like this more jiggly-like animation, because there's also this outward pressure in the normal direction. And of course, you know it, I know it, everybody knows it. If we use if you use a vertex group to control the scale, now you have basically a pressure group where you're gonna see that certain parts have less pressure, certain parts have more outward pressure. The more pressure you add, like the more like the each face or each vertex is going to try to push out. So if we delete this and bake again, oh god damn it, and bake again, you're gonna see that everything is gonna be floppy again, and that is because unfortunately vertex groups only work from 0 to 1, so I'm gonna have to multiply that because I need like a stronger force, right? Because if you see this, it already kind of works, but it's a little bit too floppy, right? So what we can do, what we can do is just multiply this. We have a math, multiply, and let's say we multiply this by, I don't know, 10. 10 is too much. Let's say 5, okay? I don't even remember which value I put there. Probably 6 or something, right? Yeah, it was 6. Anyway, let's see how we're faring now. Go back to the first frame, and you can see that you have like this weird thing on the belly button that just pushes, is like pushing out, and that's like my crappy vertex group. That's the issue with like my crappy vertex group, right? You could just like make it better and like put 0 here, and it wouldn't like push out, right? Anyway, this is what we have right now. It's kind of right? It kind of works, you know, if you're doing something, you know, let's say vigorous motion, it works. And of course, we still have the option to control basically anything here with another vertex group. So what I decided to do was to add a damping vertex group. Let me just show you how it looks like. The damping, basically, I realized that everything on the belly was like flopping around too much. So basically, one, red means more damping, blue means less damping. So all the parts that you want to, flop around and like move in like a more crazy way, you put more blue, less weight, and the parts that you want to flop less, you put more weight. And of course here we're gonna need to multiply this because the default damping is 1, and we can just do, I don't know, multiply this by 4 or like by 10 or something crazy like that. And that would mean that here in the belly area there's gonna be like a lot more damping than on the chest area. That's what we want to keep, right? And let's see if it worked. It mostly did. This is like the basic stuff. Of course, you can also control the like stretchiness and the bendiness with another vertex group. I ended up using just the mass vertex group for everything, with just those adjusters here and stuff. Let me just show it with the old one. And of course, you can like have different baking nodes for different sections of the body. I just like made everything into like one big group, one big thing with like different vertex groups and stuff like that. You could in theory like have like a completely different effect for each like group, right? And if you want like more control, you could like, instead of using just vertex groups, you could separate this in like multiple simulations and stuff like that. So I just needed to rub it in how powerful this is. So I just duplicated the mesh and added some stuff here. So it's a skirt now. It's a dress. I have like a little pin group here just on the collar area, so we don't have any sudden undressing issues, because that could happen, And I don't know, I've been like showing the bear model this entire time. Maybe YouTube just doesn't like that. Anyway, I forgot to explain here, but this is like the entire node setup. Let me just hide this. There you go. This is like the entire node setup. It's very simple. So here I'm gonna use the collider thing, right? I just set this the body mesh as a collider. Make sure to check deforming because it deforms over time. Otherwise, it's not gonna count the forces and stuff. There's friction and a little bit of softness. Let me just put like a little bit of softness there. I don't know what this does, but it'd be better if there's a little bit there. I tested this. And so as a force, I'm gonna just put 0.25 on X, 0.5 on Y. And there's like this node here that you gotta use. It's called a combined bundle, because this like green line here is a bundle. There's like a bajillion like little things here. If you press tab, all of this goes into one wire. So basically you need to use this node if you need to 2 or more nodes in the same like effectors bundle socket is what I mean. Okay, so all that said and done, I used the subdivide mesh here, and I messed around with the things a little bit. So let's see how well it works. Maybe change the collision distance a little bit to 0.005 or something like small like that. Oh, it didn't explode. Curious. That's a lot of wind. There's collision all over the place. And yeah, It's a very dense mesh. It's basically almost like it's 2 FPS instead of 2 seconds per frame, you know? And look, the quality is actually quite decent, you know? So let me just bake this and then add like a smooth modifier after the geometry nodes, so we remove a little bit of those like jagged edges. Unfortunately, this cloth solver still doesn't have like self collisions. You could technically probably do it somehow by like separating parts of the model and like setting them as colliders. But the self collision part does not exist yet. So yeah, this is baked. See how easy that was? Of course, there's like this right here, but you can solve this pretty quickly. Just add more you add more sub steps to the animation here. Let's say you put like 15 or 20, and then you add more constraint steps as well. And then this right here, this like clipping and stuff is gonna disappear, or you just increase the margin, you know. But yeah, jiggly jiggles, Batman. 30 FPS. My computer is not the best, but yeah. Anyway, if you liked this video, give it a like. If you disliked it, I'm sorry YouTube recommended you this. If you specifically disliked it because it's a tutorial on Jiggle Physics and you think this is like objectifying women, I never said you could only use it for boobs. You can definitely, positively, I tested this, use it for balls as well. So there you go. Anyway, that's gonna do it for this video. Bye.